รื่องใหม่แล้วเดี๋ยวต้องไปซื้อเครื่องใหม่แล้วเพราะเครื่องมันพังแล้วบูตแล้วก็ยังไม่ดีขึ้น CPU มันเสียโอเค Let me start from the topic on nonlinear regression. That's right. Previously, we talked about the simple and multiple linear regression. And then I also introduced you about the technique to transform from nonlinear to linear. But for this topic, we will focus on the nonlinear. That's right, not transformation to linear. As we can use Excel, we can use Minitab and apply for the nonlinear regression for this. For the first example, I will give you the optimization by Excel solver. You can use Excel solver or you can use Excel Cosec. Right. But Excel Cosec, we have only one parameter that you would like to estimate. You can use Cosec. But if you use the solver, okay, we can use the multiple parameter for estimate. For this example, we try to with this y equal to a 1 minus e power minus k to power n. It's quite complex equation. That's why it's difficult to convert to linear. And then you can use the nonlinear technique. But for this case, I have two techniques. We can use Excel or we can use the Minitab. But in Excel, we call the optimization technique. For that case, it's trial and error. For this, we have the x and y. This is the independent variable x, dependent variable y. Y is the function of x. Follow this equation. Right, follow this equation. You would like to estimate a and k in three parameters, a, k, n. This is the constant value you can obtain from the experimental data. Right, this is nonlinear. We have three parameters to estimate. We have two techniques. You can transform this to linear, but I argue this is quite difficult to transform from nonlinear to linear. Okay, for this example, we will apply nonlinear technique by optimization. Right, optimization. But technique we call the solver in Excel. Right. The technique is the simple. We try to assume k, a, n aside using k, n, and then you calculate the y value until you get the correct answer. Aside for this case, we will optimize the error is equal to 0 or minimize the error. That's right, minimize the error. Right, for this case, we call residual. Right, residual. Okay, the first step, you have to assume a k, n. For the example, we assume a k, n equal to 1 first. That's right, you know a k, n equal to 1, and then you calculate this equation, right, for this Excel. You calculate y equal to a, this is a, multiply 1 minus e power minus k, this is k, t power n, this is n, and t, this x is t, right? This is the variable x is t for this case. Right. And then you calculate y at any t, right? Y at any t, I show you. Right, for this, right, for this you substitute the first guess for a k n, that's right, a k n, you get y, right? You get y, and this is t, right? Temperature, time is x is time for this, and then you calculate for it. This is the y predict, right? Y predict. This is the actual y or the data or the experimental data. The technique you like to compare the error between actual data and predict. For this case, you calculate based on residual or error, right? Y minus y predict, and you use the I will use the square error, right? Y minus y predict square. This is the square error. You get the positive, right? And I talk to you if you sum up of the error based on this, it may be negative, it may be positive. Sometimes error will be reduced based on negative and positive cancel. Okay, you have to solve it by square or use the absolute error aside. Okay, and then this is some square error. Sum of this, you get about 1000. It's very high error. The first get, and the next step you have to try out to get a kn again. It's maybe 2, 3, 4. It's up to you. Do this until you get the real answer. Until you get the SSR approach to 0. That's right, approach to zero. For this case, we call it trial and error. But in the Excel, we have at least two programs. The Excel we will use the technique to optimize. That's right, by program. That's right, by program. Okay, I will show you in Excel. Right. อยู่ไหนเนาะ Okay, for this I will check like this. If we back to this, we will get one is it the correct answer because we solved by Excel already. Okay, but for this we will try the first case is for this case you have some constraint that KAN value should be greater than zero, right? Okay, for this you the first case. For this case you right, that's right. This is A, right, A. For this A, we click F4, right, or $A, $29. This is A, 79 cell. 29 is the value of A, that's right. Multiply 1 minus exponential K, right? Exponential K. K is cell B29. This is B29. And also we pick cell $B, $29. We use it to pick cell, that's right. And multiply T, that's right. T is A, column A, that's right. A2 for this. And power N, N is cell C29. This is the first law, right? Okay. And then also you can copy like this, right? Then copy to the last cell, right? And then you get the equation the same, but only change column A, right? A, K, N still is the cell 29. Change only A, that's right. This is A2, A3, A4, right? Another is the same because you get this is Y predict, right? Y predict, and then you calculate error. But for this case, we use the square error. That's right, square error. This is the column B minus column C and square. This is B minus C square. That's right. This is the B minus C and then C square. This is the error, right? Okay, and then you sum error for this. This is sum of E2 until E25, right? This is the sum error because we try to minimize or to set this value approach zero. If it's approach zero, that means the actual value and the predict value is close to the same. That's correct. Your AKN is close to the same answer. Okay. The first this is the data. The real data we plot this. We plot X, that's right, Y and X. This is Y, this is X. We would like to find the fitting equation. This is nonlinear. That's right. This is nonlinear. Okay. And then you go to data, we have solver. Right. And again, if you have no solver in your Excel, you can call for as in by option. Right, okay, but right now we have solver. The objective you would like to set this cell, let's say E79. This is sum of square error approach zero. Right? The value that we have to maximize, minimize, or the value approach zero. Right, for this approach zero. And then we the parameter that we would like to estimate, you select all of this three of AKN. That's right. You select AKN by this. This is from A29 to C29. We would like to trial and error by predict these three parameters. That's right. Okay. And also if you have some constraint, you can add, right? If you know, right, the AKN should be greater than 0 or KN is between 1 and 2, you can do that if you know. If you don't know, okay, you do not add to this. And this is the technique. We have a lot of technique in the optimization. I did not talk to you about this. We have at least three methods for optimization. That's right. Okay. And this is the iteration. This is right. The result is the precision. And this will be about 100 times. You can try out another 100 times maximum for this, right? For this case. You can add 100, you can add cycle, and if you check with 100 first. Okay. And then now we solve this. You get this answer 12. A K is 1.5, N is 2.5. You get this. And some square error is 6. I would like to check this is accurate or is correct or not. I just have some R square ready for this. If I plot, you plot this. Okay. You plot X and predict. Like this predict value, right? It's code to the correct one, but I think we can modify this. That's right. You can do this again because this maybe some not perfect code that you get about 0.98. We can include the R square for this if I see. Okay. Okay, for this case, it's maybe for the slide. What is the slide? Right, the slide is 12.2, 1.6. Okay, it's equal to the correct one, right? If I increase the number of iterations, I would like to check this. This is we also good prediction, but if we ask number of iterations, like for this case, we would only 100. If you add about 1,000, that's right. If about 1,000, we can do that or not. I will check this. Right. Yes. You can find that data is improved, right? The best better than previously because the previous we have only 100 now, but sometimes you try out another 100 times, you get the result. But sometimes it's not perfect. You can trial and error again. That's why you add the number of trial and error. For this case, you increase higher than 100. Okay, you get the best answer. Right? You get the best answer. But if I add more than 1,000, you get the same or not. I will check this. Like this. This is 11, 6.6. Okay, we get the same, right? Already because right, only 1,000 is maybe show this is good result already. we get the R square is 0.99. From previously, we get R square is 0.98. That's right for 100 for that case. Okay, you can improve this. We have to check because the number of iteration. That's right. Number of iteration, the number of that you get AKN value. That's right, AKN value. And also for this case, I show you how to test another, like we calculate R square by this formula. Right, R square we can use the Y and X data from experiment compared to from prediction. That's right for this. Right, this equation and this equation you can use both of this. Right, I think I show you already. This is the R square. That's right. You can calculate R square. This is I calculate for you already for this. Right. R square equal to F29. F29 is sum square error, right? S minus SSE divided by S, right? This is right. Okay, this is S, right? S. This is SSE, right? You can calculate R square. This is the technique. If you fit and the result is not good, okay, you can increase the number of iterations. It maybe can help you for that. Okay, this is the example that I fit the nonlinear with the optimization technique in Excel. Like this. You get the same result with like this. Like for the first time, when you fit it's not perfect with, okay, I can increase the number of iterations like from 100 to 1000 can help you like for this. And then you improve the fitting, like the best fit, right? From previously is 0 point, right? Okay, it's not good. 9, like 1. Like this, it's not perfect. And then you improve by increase the number of iteration or the population size for this. You get the general equation that this equation can define the data. The data like that. Okay. And another technique, for this case, we can transform to linear. Okay, I talked to you already for this example. This is another example, right? The rate of reaction is a function of CA in terms of this equation. This equation is the common known is linear equation, right? This is the linear equation. If you talk about the absorption, what commonly describe this. Right? And also, if you don't like to transform to linear, you can use the Excel, right, for solver. For this case, we have two parameters, K1 and K2 for estimate, right, for estimate. And also, you can transform from nonlinear to linear. For linear to you plot 1 over R and 1 over CA. You get slope and intercept this. Right. For this case, it's easy to transform from nonlinear to linear. Right. You fit the like this. Right, for this case. It's the same as I talked to you already for this case. Right. Okay, and this. Okay, for this data, if you would like to use the nonlinear, but for this example, I show you by Minitab. Like Minitab, we fit this equation with Minitab, but for Excel, this I only show you like last week. Okay, but for this case, we apply the Minitab to estimate K1 and K2 of this equation, right? K1 and K2 of this equation. That means you have to input the data, right? CA, RA is running with CA in the Minitab first. I think we have the data in Excel already in example 2, right? Okay. In example 2, right? This data, right? You have to copy this data to Minitab. Okay. Right, for this you can see that. Okay. And then in Minitab, you have the regression, but for this we select nonlinear regression. The last week we only the regression fit model with regression, but for this we select nonlinear regression. That's like nonlinear regression. And then the response means the dependent variable or y. You select RA, right, for this case. You can use the catalog. Catalog means show some equation. That's why this is equation, right? Some equation. This is we have the equation. This is 1 minus 1 divided x power theta. This is the itself, right, for this. And also, you can use the calculator, right? It's a function, right? Or you can type the equation, right? For type the equation. For this case, the equation is right, K1 multiply CA divided by K2 plus CA. That's like RA is a function of CA, like this. Minitab. Okay, for this case, you can calculate A. Right, A is constant. A multiply CA, right? And CA, right? So select CA for this, right? And divide this B, sorry. B plus CA, right? Plus CA. Okay. Right, this is the equation for this. And then you click the parameter, right? You have to add the initial case. It's the same Excel, right? You have to input the initial case for this. What is the initial case? For this, the program we know CA because you click CA from this CA is variable, right? Okay. For this case, I should 1 for initial. You can choose another value, right? Okay. If you have some constraint, right? It may be A is between 0 and 2. If you know A is between 0 and 2, but you don't know exactly the number, you can add this. Right? You can ask it. The lower or upper, you can ask. If you know, if you don't know, you don't worry about that. Do not ask for that, right? For this. Okay. There's many you can the option what the number of the iteration like 200, 100, 2000. That's why this is the tolerance about 1 power minus 5. This is the 95 confidence interval, right? For example, the some predict, right? For this we have fit. You have to test all this or not, right? You have to plot the curve or not. This is the residual plot, right? You can plot the residual. You like to test your model is accuracy or not. That's for that case. Okay. If we click OK, right? Okay, this is the residual, right? Right. Okay, this is the curve. That's right. The fitting curve for that, right? This is the equation that means R equal to 0.692 CA divided by 4.2 plus CA. Right, you get this result, right, for this. And how about the result? We use only iteration is S time. You said maximum is 200, but for this example, only S time, right? You get 1, K1, 1, K2, 1, and then the program do only S time. You get the answer, right? Trial and error S time ก็คือสมมุติค่าแค่8 ครั้งเองก็ได้คำตอบนะครับ Okay, we have some this is the standard deviation. You get this for this. Okay, this is for nonlinear technique, right? And also what the iteration number is 2000, but for this case we use only S time, right? The technique for this we use Newton technique, right? For this case, but according to, but I will not to talk to you in detail for this is the optimization class, right? Okay, this for nonlinear in Minitab. If you use in Excel, okay, I talk to you, use the optimization by solver. By solver, it can be 1 parameter or more than 1 parameter. And also in Excel, we have GoSeek. If you go to what if analysis, we have GoSeek. GoSeek that we find the goal. What is the goal? But for this case, we have only 1 parameter. Like if you use GoSeek, use it for 1 parameter only, like that. Okay, for this, what is the next example, right? Like this, okay. Is it for, we can use this for linear also, that's right, it's for nearby this case, x1 and x2 we can use also, right? We can use the nonlinear technique to predict linear also, that's right, with this. But the same, you add the equation, this is y equal to a plus b x1 plus c x1. This is multiple linear, that's right. This multiple linear. You can use as I talked to you previously, that's right. And also you can use this technique for this because this is the optimization. We can use linear or non-linear. We can assume parameter. For this case, we assume 1, 1, 1 for initial case, that's right. And then you get the result like that for this case. And this is this probably some Thais we copy from my book. Well, about very old book about 6 years ago. I teach in Burapha University, right? For that case, okay. You would like to fit the vapor pressure of benzene vary with temperature. We have many equation, many theory. You can use the right first order polynomial to fit the vapor pressure of benzene, or you use the Young equation. This is, and or you can use the equation for this. Right. When you have some data, would you like to fit? We have many theory. That if many theory is also is different assumption. You would like to fit your data follow with theory. For this case, we have 3 theory to describe the plain water pressure. Right. For this is example 5 for that case. And also, I use the nonlinear technique for this. Right. Okay, we have some data. This is for polynomial, right? This for polynomial. This is like this. You can type this. Okay, get for 1, 1. And then you get result. P star. Right. Like this is the fit curve. Right. I will show you later. Right. But for this, if we represent by the Young equation, is log P star. This is in terms of log P. Log P star. Right. Okay, you calculate log already in column C3. Like this. Log P star equal to A plus B divided by T. Like this. Right. For this. And then you get the list also. Right. And the last one for this case is A plus B over T plus C. We have log. For this case, you have to add some calculator help you. That's right. We have to add log from function. Right? But okay, I will show you in the last example. Okay, for the example, right? For example 5. Example 5 like this now. ไม่มี data หายไปไหน ฉันลืมเขียน Okay, sorry. We have no data for this. We have no data, but okay. I will upload all data. Okay. Okay, I will break for 5 minutes อาจารย์ขอหาข้อมูลก่อนพอดีอาจารย์ลืมเซฟเนี่ยเลยหายไปหมดเลยนะครับ Okay. And after that, I will talk about the ANOVA analysis. Okay, I will break for 5 minutes. I will find the data. โทษทีอาจารย์ลืมเอาข้อมูลมานะครับแล้วก็ลืมน่าจะหายไประหว่างทางจากบ้านมานี่ไม่ใช่